Welcome. Today we would start with Goh Cheng Leong, the fourth chapter, where we would understand the concept of weathering, mass movement and groundwater. Now indeed all of these are very elaborate topics, however we will be covering all these topics in summary in this lecture. Now first of all, when we talk about the origin of the earth or the formation of the various features on the earth, we talk about two fundamental features that affect it, or two fundamental factors. The first is the internal factor that occur from within the landform, that's formation of the mountain. So let's say you have a mountain here. So all the features that are occurring within the mountain would be the internal features, and those would include the process of folds, faults. So in simple terms, the process of mountain building, which is known as orogenesis, is talked about when we talk about internal forces. When it comes to the external forces, we talk about all the things that come into action which affect the landform externally. So what it would be? It would be all the moving agents, and those moving agents would be wind, water, ice, you have snow, so all those, you have waves, so all those affect the landform formation, but they affect from outside. So all these are known as the moving agents, and these moving agents lead to the process of erosion. Now there is a difference between the term weathering and erosion. When we talk about weathering, it's simply disintegration or breaking down of a bigger particle into smaller particle. So that is weathering. When we talk about erosion, it is moving of these weathered materials along with either of these agents. Now of these, we can say winds are commonly seen in desert areas, ice and snow commonly seen in the glacial areas, waves commonly seen in the coastal areas, but among this, water is one which is present everywhere, and in the next class we would talk about the landforms which are formed by the action of running water. So we would go into the details of each of these landforms, the moving agents that lead to the formation of various landforms, both erosional and depositional, in the next lectures. Coming on back to the topic, so we have weathering and erosion as the two fundamental processes. Now what ultimately is the aim of the landform? The aim of the landform is to lower down the surface area, and this process of lowering the surface region is known as denudation. So what occurs in the process of denudation is, this is a mountain, it would erode, so the rocks would weather out here, it would erode, and ultimately this mountain would degrade in height or lower in height, and that process is known as denudation. But if it was a process that the denudation is occurring constantly, you would have all the fields that would have been leveled. So denudation occurs along with the process of deposition. So whatever material is going from here is ultimately depositing somewhere. So let's say you have a mountain and then you have a valley area. So this mountain is eroding, and then this eroded material gets deposited in this valley region. So that explains how the landforms keep on changing over the given duration of time. So you have, after the erosion, the eroded material which are moving with the various agents are transported to somewhere and finally deposited. Now what all factors affect the process of weathering, erosion, deposition and transportation? It's definitely the relief. If the rocks are very hard, it won't weather or erode easily. So relief, the climatic conditions. So as we will talk further, we would talk more about the methods of weathering, and we would understand how climate plays an important role in weathering. Then you have human interference, human activities, animal interference, biotic factors that all affect the weathering and the erosion. Now, we would first talk about weathering, and then we will move on to mass movement, erosion and the moving agents we would be talking about in the further lectures. So, weathering basically can be explained in two types. It can be either chemical weathering or physical weathering. So, when we say it's chemical weathering, it's due to the action of the chemicals. There are various types of chemical weathering which we will talk about, and under the physical weathering, it's due to the mechanical action or the physical action that is seen and that leads to the physical weathering. So when we talk about chemical weathering, let's say if it is a calcium carbonate rock, mainly a kind of limestone topography which we see, if water reacts with calcium carbonate, what it would form? It would form calcium hydroxide, and this calcium hydroxide is soluble. So what happens is the limestone rocks are ultimately converted or dissolved into the water, because in presence of water they form calcium hydroxide. So that's one example to explain how chemical weathering takes place. Definitely, chemical weathering is a slow process. It occurs gradually over the time period and leads to the decomposition of the rocks. So let's say if you go on to Kentucky or any of the limestone caves, the Crust topography, the underground topography that we would study further, if you go to any of the underground caves, you won't see those caves being formed in one night or a kind of 1 month period. It's over the years that these rocks slowly and gradually decompose and dissolve, and finally you have the various features in the underground topography or the karst topography, what we say, which are visible. Now good examples here are in Malaysia. So in Malaysia you have granite features. Now these granite features are pitted and rough. Why they are pitted and rough? This granite is made up of three major elements. Those are quartz, feldspar and mica. Now among all these three, you have feldspar that weathers at a faster pace as compared to quartz. So what happens within the structure of the granite? You have quartz, feldspar, mica. So the regions of the feldspar would weather away, and you would have quartz that would weather at a slower pace. Therefore, the granite topography is seen as rough and pitted. Pitted means you would see small depressions or holes throughout the region. Again, you have a kind of underground topography. You have within the topography the core stone region. Core stone region is the central region within the regolith rock or the bedrock, and you have minimum number of joints that are seen here. So here you find minimum weathering. However, as you move closer to the surface, what would happen? You would have more joints that are seen. Since this region has higher number of joints, you would have higher amount of weathering that would be seen in the region. And the center part of the rock would ultimately sustain, because the amount of weathering in that central portion would be much less. So let's talk about the various methods or the various types of chemical weatherings. The first weathering is solution that we already talked about, common in the regions where the rainfall is heavy, the climate is warm and wet basically, and minerals dissolve into water. So limestone topography is a very good example of solution. The next is oxidation. What is oxidation? Oxidation simply is the rusting of the surface. So you have iron, when exposed to oxygen, forms iron oxide, and this iron oxide basically forms a layer of rust. This oxide is a rusted layer, and that process is known as oxidation. Then you have decomposition by the various organic compounds. So that is done mainly by the action of bacteria which are available through the plants and the animals. So these bacteria go into the soil, they decompose the soil, and they decompose mainly the organic acids, and finally you have the weathering that is seen. So those are the common weatherings which we talk about under chemical weathering. For a detailed lecture on weathering, we have the link above, so you can just go there and visit the detailed lecture that we have already covered on weathering. Now coming on to the next is the physical weathering. Now physical weathering can be of many types. The first physical weathering that we would talk about is repeated temperature change, commonly seen in the desert area. What happens is during the day the temperature shoots out and it increases. During the night the temperature falls. Then during the day it increases. So there is a kind of repeated temperature change that is seen. Now this repeated temperature change, what would happen is During the daytime, the rocks would expand. During the night, they would contract. So there would be a kind of continuous expansion and contraction that would be seen. So shales and slates basically split out in this manner, and when they split out, they form the plates, or it is known as the platy fragments, also known as exfoliation or onion peeling. So if you peel out an onion sometime, you would see onion can be peeled out into different layers. Similar to that, due to repeated temperature changes, you would have a peeling that would appear similar to what you have in the onion, and that process is known as exfoliation. The next is repeated wetting and drying. Now in the region where there is continuous heavy rainfall, what would happen? There would be a continuous rainfall. So you would have, let's say, waterlogging in that area. Now suddenly rain stops and sun comes out bright. What would happen? This region would suddenly dry out. So similar to the temperature changes that we have seen here it's mainly the water changes or the precipitation changes, in the correct way we would say, commonly seen in the tropical areas, mainly in the regions of Malaysia, and you would have the features that would be formed due to repeated wetting and drying. Now this repeated wetting and drying is also commonly seen in the coastal areas. So in the coastal areas, what would happen is you would have sudden waves that are gushing in, and suddenly you have sun that comes out and waves retreat back. So this region which was wet suddenly dries, and due to the change in the amount of water in the soil structure, you would have the weathering that would occur. The next is frost action. Now what happens is, we very well know that water, when changes into ice, it expands. Now just this simple logic would help us understand this problem. So what happens is, in the hilly areas or in the temperate areas, you have a rock structure. Let's say this is a rock, and you have this depression. This depression is filled with water. Now during the frost period or the winter periods or the night, this water freezes. When this water freezes, as we know, water forms ice, and when it forms ice, it expands. So this region would slowly and gradually try to push the rock structures on its surface, and therefore you would have a deepening of the structure that would be seen, and that is what is frost action. So as we said, frost action is commonly seen in temperate areas, hilly areas, where the temperature drops suddenly at the night and deep cracks are formed. So these angular fragments which fall onto the foot of the slope. So once what happens is, sometimes you have these structures that are formed and this rock breaks off and it falls onto the foot of the mountain. So the rock from here would break off and fall down, and that would be known as screes. So that's again very important. Now what would happen with the action of biotic factors? With the biotic factors, let's say you have a rock, you have a plant that is seen here. Sorry, I drew a human instead of plant. So you have a plant here. Now what would happen? The roots of this plant would go deeper. So you would have the roots that would go deeper and they would crack the soil, and there would be physical disintegration. Now this is simple if we see on a plain area. What would happen if it is a kind of hilly terrain? If it is a hilly terrain, it becomes further difficult because you have a tree here, and this tree deepens its root. So what would happen is, this tree, when it's deepening its root, it would break the soil from this region, and from this region itself you would have small soil particles that would tend to go down or move down. So that's what is the biotic actions, where the soil is loosened at the joints. Basically wherever the joints are there, the soil becomes loose. The next is mass movement. Now mass movement again we have covered in detail in one of the lectures. We would be covering the major highlights in this class. Now when we talk about mass movement, in simple terms we can say whatever material is being weathered moves to the base by the force of gravity or due to the gravitational force. Now I have an example here. I have some dust here. Observe this carefully. You have a mountain here. I drop this sand. This is, let's say, the weathered material of this mountain itself. When I drop it, it flows down and you can see all of the sand gets deposited down. So that is what is mass movement, commonly seen in the hilly terrain. So those who are from the hilly terrains can nicely visualize it. Now let's say there are two mountains, one with a steeper slope and one with a less steep slope. What would happen? The movement of the dust or the sand, we could say, in both the cases would be different. Here the movement was much faster because it's a steeper rock. Here it's a gentle rock with less slope, and therefore the material would move at a slower pace. Here the pace of movement would be much faster. So based on that, you have a soil creep or a landslide that is seen. So that what we showed was a kind of example of a landslide, we could say, or a kind of soil flow. If it was water, it would have been a soil flow. So difference between soil creep and soil flow, first of all, soil creep is very slow. So on a gentle slope, you would see a soil creep. So you would have the small particles that roll down. So more or less in a kind of continuous fashion, with an area where there is gentle slope, and this is commonly seen in the areas where you have damp regions or damp soil, and water acts as a lubricant and allows the flow of these particles down the hill. So that's what is soil creep. Now soil flow is a simple process where you have the soil particle that's mixed with water and it forms a kind of mud and is liquid and flows down. So rather than rolling as a sand particle, if I mix water in it and I demonstrate, it would be an example of soil flow. Now soil flow is commonly seen in the areas where you have rainfall. So what happens immediately after rainfall? All the small particles, sand particles, rock particles get dissolved or mixed with the rainfall and they flow downhill. Again, this soil flow is very common in the arid areas, because in the arid areas the saturation comes with the rainwater and you have a continuous movement that is seen. Again, soil flow is seen in the peaty soils where the peat absorbs most of the moisture that is there, and sometimes this is even known as bog burst, that is called in Ireland. So those are the examples of soil flow. Now coming on to the last, that is landslide, where we talk about two things, slumping and sliding. Now slumping and sliding, there is a kind of difference where we try to understand the two terms. So when you say slide, it's simply you have a mountain and the rock slides down. Now this process of sliding occurs when the rock is steeper. So if it is this kind of rock, the mountain, you would have a higher flow of the rock material that would be seen. Again, what happens in slumping is you have the rock pieces that are arranged in this fashion, and below this rock pieces, let's say you have a kind of water channel that is flowing. Because of the water channel, there is lubrication that is seen, and this part of the rock flows down or slips down, and that process is known as slumping. So you have whole of the blocks slumping one after the another. That's the correct way to explain it, and therefore we call this process as slumping, and this process would be explained as sliding. Both of these are examples of landslide, and under landslide basically it's seen in the areas where the slope is steeper as compared to the other region. So as you can see, whole of the region moves down. So this whole rock piece would move down under the process of slumping. So if you actually realize it in the real world, you would see this kind of structure that could be seen, and that is what is explained as slumping. Now slumping is commonly seen where you have clay region. The soil is initially dry, but when it comes in contact with the clay, it basically cracks from certain region, and therefore wherever you have the cracks, you would have the movement of the rock particles that would be seen, and the slipping of the rock material, and that slipping is known as slumping. Again, one interesting thing to note is you have, let's say, a vertical pole of electricity going through this region. Now what would happen during a soil creep? You have a soil creep that's occurring, and during the soil creep what happens is this vertical pole would be pushed by the action of the soil particle. So this vertical pole would tilt, and therefore on the hilly areas, or if you go on to the any hill stations where there are frequent landslides, you would see most of the poles that are seen are tilted and are not vertical. So that's again very important to understand here. Now the next topic that we talk about is groundwater. Groundwater, in the simple terms, we can say whatever water is present in the ground is known as groundwater. Now where does this water comes from? So this water comes through the process of hydrological cycle that we have discussed in this class. Now under hydrological cycle, what happens is you have the water circulation that occurs between the land, water and atmosphere. So you have evaporation from the ocean surface, transpiration from the plants, and ultimately the water forms the clouds. This clouds occurs as rain and finally moves, or either goes into the water body or goes into the groundwater and percolates down the groundwater. So once this water, rainwater, percolates down the ground, you have the groundwater that is formed. Now groundwater occurs in various layers. The lowermost layer we would say is the layer of saturation or a kind of permanent groundwater. So what would happen is this region would have a permanent amount of water capacity that would be seen. However, the upper layers would change or vary based on the amount of rainfall, and that layer is known as water table. So what would happen during the rainy season? This water table would go up. During the dry periods, there would be scarcity of water and the water table will go down. Water table goes up, that means you have more water that is available and the groundwater is highly saturated. During the dry seasons, it goes down. Again, what would happen in a hilly area and a valley area? In the hilly area, the water table is usually very low, so you have to pump out water. However, in the valley areas, you have sufficient water that could be seen, and since there is sufficient water, sometimes there are cases of waterlogging that are also observed in the valley areas or the lower areas. So that's one of the fundamental things to talk about in groundwater. The next important thing is the concept of porosity and perviousness or permeability. So when we talk about porosity, we have rock particles that are arranged in this fashion. Now when these rock particles are loosely arranged, what would happen? The water would run through the channels in between. So whatever portion I fill off would be water here, and this portion would be, this rock would be known as porous rock. So a highly porous rock would be, a good example would be sand. A less porous but definitely porous would be clay. A non-porous example would be granite, where the particles are very tightly packed and there is no intermittent space that is seen. On the other hand, you have permeability. When we talk about permeability or pervious rock, what is important to understand here is, under the pervious rocks, you have the rocks that are arranged and in between you have joints. So water percolates only through those joints. So you would have the water running through this joint, then going this way and running through this joint, and so on and so forth. So that is an example of permeability or permeable rock. So there is a difference between the two. Now let's come on to two good examples. Let's talk about clay first. Clay is definitely porous, but it is not permeable. So it does not have joints through which it would percolate down. However, the other example is granite. So granite on the other hand is not porous, it's tightly packed, but it is definitely pervious or permeable, because through the joints you would have the movement of water that would be allowed. So that's the two difference, or the difference between the two things and the examples for the same. So that's again very important. Water table we have already discussed. Now coming on to the idea of springs and wells. First of all, let's make it very clear what's a key difference between a spring and a well. Well is man-made spring is natural. Now when do you bore a well? Let's say in the dry areas or the dry desert areas of Rajasthan, for example in India, what would happen is water is not available during the water is available only during the rainy season. So there is two ways of water conservation. What we talked right now these days is the idea of rainwater harvesting. So store the rainwater that is there and use it in the dry periods. The other is digging out the wells. So what happens when you dig out a well? When you are digging a well, you would dig it based on the different layers. So you would have one well that is dug here, the other here and the third here. Now what would be the difference in the three wells? The first well would go dry in most of the seasons because the water table is not up to that mark. This well would have water during the rainy season and water would be available only during the rainy season. However, this well is sufficiently deep and can take out water throughout the year because it's on the permanent water table that it lies, and therefore this would be an example of a permanent well that would bring around water in all seasons. So that's the basic idea to understand the wells. The next is the concept of artesian well. That's basically the well that is formed due to the nature of the formation we call about as an artesian well, and that artesian well is commonly seen in the areas of Australia. So most of the Australia you have artesian wells that are seen. Now springs. Springs is the natural flow of water that is seen. So it can be as a gush of a fountain that could be seen. You can have hot geysers that could be seen. So all those are examples of springs, but right now we would focus only on the springs. Now where all you can find springs? First of all, you have a rock structure, you have a river flowing through, and suddenly there is a kind of permeable rock here, and this river gets a exit point and it flows out. So it becomes a spring. So it would work out or flow down here, and that would be an example of normal strata. The next is you have a kind of well jointed rock that is seen, and from this well jointed rock you have river that is passing in. Finally, you have a kind of permeable region that comes out and you have the spring that is formed. The next is within the rock you have a dike, and this dike acts as an impermeable layer. So as soon as the dike is over, you have the fountain that comes out, and that's again an example of a spring. Then you have volcanic springs, those are known as resurgence springs. So what happens is you have a river that is seen on the top. Then you have a mountain, this river goes down and suddenly re-emerges back. So this river was above the landform, went below the landform, and then again emerged out of the landform, and that is what is known as the Volcanian or the resurgent springs. So hot springs, geysers that we already talked about are good examples of springs. We have already talked about well. So with well you dig a hole and you have a continuous flow of water based on the depth you are digging that hole. So if it reaches the level of aquifer, you have a kind of the aquifer is the permanent saturation zone, and once it reaches the aquifer you have water throughout the year that could be seen. Now the depth of the well varies. It's commonly seen, as we said, in the desert areas. So Australia is a good example, Sahara Desert. In India you have Thar Desert in Rajasthan. So all those are the examples where you have wells that are seen. So with this we cover the 4th chapter of Goh Cheng Leong. We will be covering the next few chapters where we will be talking about the landforms that are formed by the various moving agents. Now these moving agents we understood when we talked about the idea of erosion. So we would see the action of those moving agents in the formation of landform, and each element or each agent would have two factors that it would affect. So one would be the landforms that are formed due to the erosional action, and the other would be due to the depositional action. We will talk about those more as we move further in the upcoming lectures. So definitely stay tuned. If you have any doubts, you can leave those as comment below the video. Subscribe to the channel. For Hindi medium students, we have a separate channel as Examrace Hindi. You can definitely watch out these classes there. Have a very good day ahead.